Hello. So today I'll be introducing to you some functional groups in organic chemistry, especially in biological molecules. So let me start. Alkanes, as you have learned, they are not a functional group because they are the basis of forming other more complex molecules. So remember, they are not functional groups. Okay. Now, the first functional group you will see will be an alkene. Alkene having carbon-carbon double bond, right? You can see it in molecules such as this. Remember, 1, 2, 3, 4 carbon atoms, and I put a double bond here. So this is butene. But 4 carbon alkene. Next, we have alkyne. Alkyne means having carbon-carbon triple bonds. So, if I may draw this skeleton structure, you notice this ends off with a carbon. Don't forget, 1, 2, 3, 4. So in total, again, 4 carbon, butene. Do you see? The suffix are always similar. In ends with in, alkyne, butene, 4 carbon. Later on, I will be telling you more about where to put the numbers because if you have realized, this double bond could be in the middle or by the side. There are some subtle differences in the naming. The next functional group would be an arene. Right. Arene means having a benzene ring, a hexagonal structure with a ring in the middle. So this is synonymous to drawing a hexagon with alternating pi bonds. So in this 6 carbon member cyclic ring, there are alternating double bonds inside and close together, making it aromatic. We call them arenes. So for this molecule, we have benzene. The next functional group is the alkyl halide. In short, we call them Rx. R in organic chemistry textbooks, you might see it many times, capital. This stands for the word residual. What is the rest of the chunk after having that functional group? So this R normally will have a formula, in general, CnH2n plus 1. You might have realized that why is it 2n plus 1 and not 2n plus 2? 2n plus 2 in this case would tell you it's an alkane. By alkane, we have all the bonds being saturated. So now what I'm doing here is I'm cutting off a CH bond, making it a loose arm, and connecting it to something else. In this case, X, meaning a halogen, such as a fluorine, chlorine, bromine, or iodine. For instance, take a look at this. In total here, there are 1, 2, 3 carbon atoms, and the last carbon connects to a fluorine atom. So the name for this would be 1-fluoropropane. At the first position, 1-fluoropropane. Cool? In total, 3 carbon atoms. So likewise, if you're given something like this, that will be a bromoethane, right? Some people will also call it a halogenoalkane. So again, these are just synonyms. They mean the same thing, alkyl halides or halogenoalkanes. You can give me either one, no worries. Now next, we have alcohol, a solvent, and also a drink that some of us drink, right? So alcohol will have ROH. Let's try this. How many carbon are there in this drawing here? 1, 2, 3, 4, 5. 5 junctions. So this is a pen. No. It ends with the same suffix. That tells you the functional group.